So we're looking at some of the language features in Java, just kind of a broad review of what those are. I'm going to create a new project. So I go to the File menu, I click on New Project. This first screen, we're typically going to be doing just Java applications. Nothing more complicated than that generally in this class. In your H drive, now that we all have H drives, you want to give your project a meaningful name. So maybe I call this one Java Review. What was that? No, that's going to take a data fix. So if you could take your notes in e-access for now, and then we'll try to get that sorted out. Everybody else's are working. For some reason, yours is not. So I'll have to troubleshoot that, okay? So just call it Java Review. Put this in your H drive. Now, we had a lot of people who did all their work on their desktop, and that just scares me because the district every once in a while wipes the machine and puts a new operating system on it. I'm like, and then the student's code is lost. So you really have to store these out in your H drive. Now, I don't have an H drive because I have a different mapping, but mine's out on the network too. So don't store it locally in My Documents or on your desktop. Make sure you store it in your H drive if you have one. If you don't have one today, put it out in e-access folder would be a good spot, because that's in a different spot than the local machine. Generally, we don't want to store really anything on the local machine. Okay. And then just click Finish here. And it gives us a main method. Now, I'm going to create a new class where we're going to put some of the things we want to exercise today. Typically, the first class that's created for a new project, it gives it a name, but it also gives you a main method. Now remember, remember back in Java 1, the main method is the entry point to every Java program you're ever going to write. When you start up a Java application, it's going to call main. That's the first place it goes. So the IDE is trying to help you with that. So it creates a class that has a main method in it. Main method has a very specific method signature. It says public static void main, and in parentheses is string args. And every Java program, that's how it starts, just like that. There's some limitations though to this main method. You can't create, you can't refer to anything that belongs to an object. This is a static class. That means it's a class level class. It's not something where you can create a Java Review class from this. Everything in that class can't rely on any instance variables that belong to the object, because there is no object when main gets called. It's the starting point. So there's a lot of restrictions, and we could go into that, but it's pretty long-winded. So what I do is I have a main method, but the first thing I do in the main method is I create another class. And that's the class where we're going to put all our code in. So it's kind of a two-step process. You first create the tester class, that's what this is, and then the actual class that you're trying to make is in a different spot. Okay, so I keep those two separate. And I find that that avoids a lot of confusion. That's what most Java programmers do. So we're going to create that second class to help us do the review. So to add a class, you go to your project folder. Here's my project folder. And all of these are just other projects I've been working on, but I want to create a new class in this package. Now, things are grouped in Java in packages. If you put a bunch of different classes in a package, you can move that package from project to project. It's kind of nice way they package it up. And in this package, we're going to have a second class. So what I do is I right-click on the package name, and then I say New Java Class. Okay. Your menus might look a little bit different because the IDE kind of mixes things up. So make sure if it's not on the list, click Other and choose Java Class. And we'll call this class, just call it Review. And click Finish. Now this time, you'll note that when the IDE creates the class, notice it doesn't create a main method this time. It just creates for you the outside of a class declaration, and then it also puts it in the same package as the first class. So there's no main method here, right? You just have one. William, did you have a question? Question? All right, so we're going to start our first review question, or review item. Let's start here. Now, every class that you create has something called a constructor. And what a constructor does is it takes the object you're creating and initializes it to a state that's a good starting point. And I'll show you what that means in a second. But first I want to add some instance variables. Now, at the end of the Java 1 class, we had a date class. But I think what I'm going to do is create a two-dimensional shape class. That's going to be our kind of our exploration class. And suppose we say this. We say private int width So what we have here is a series of these are called private instance variables. So when you create a review object, it's going to have inside it a width variable, a height, x and a y. X and y would be its location on the screen, and the width and height would be how many pixels wide it is. Now, x and y is a little bit weird. If you remember from Game Design 1, remember how the y coordinate was upside down? Where the highest part of the top left corner of the screen was 0, 0, 0 for y. And then as y grew, it goes down the screen, not up. So it's like that first quartile of the Cartesian coordinate system is flipped over. Okay, you just turned it upside down. Now the origin's up at the top left, and then it grows down. X is still left to right the normal way. It's just y is upside down. So we have these private instance variables that are going to describe our object. I'm going to change the name of this class, and I want to show you what happens when you do that. Let me. There's this weird requirement in Java that the class name here inside the file, see this one that says review, is in a source file that's also called review. This is the only language where I see this weird requirement, is that the name inside the class has to match the name of the actual file that the class resides in. So if I go in here and I say, well, I'm going to change this to shape 2D, so a 2D shape, and it starts to complain. It says, well, it puts up this little warning thing, and it says, get the mouse to stay. My hand's not that steady. Class shape2d is public and should be declared in the name or the file name shape2d.java. So it sees that I've changed the name inside the file, but it's noticing, oh, well, that means you have to change the name outside of the file. So what you do is you just click here then and say rename file to shape2d.java. So I'm going to rename that. And then our problem goes away. If you look out here in our project, note that shape2d now has a new name. It's not called review anymore. So that file name change happened automatically if you click on the little button there. Now it gives us another warning. Let's see what that one says. Yeah, nothing really. Now I look at a class as like a cookie cutter, okay? And the objects the class creates are like cookies. So you have this template for this cookie. That's your class, and you're going to stamp out all these cookies. You can have lots of cookies, but you only have one cookie cutter. With one cookie cutter, you can make a lot of cookies. So our shape2d is going to be that way. It's going to be our our cookie cutter. In our cookies, we'll have 4 variables for each object. It'll be the width, the height, the x, and the y. Okay. Problem is, if we want to get access to that width or create one of these shape 2D objects, we don't have a way to do that right now. How do you tell the cookie cutter to create a cookie? You need a way to tell it, hey, can you make me a cookie? Can you make me a shape 2D? And so the way we do that is we create something called a constructor. And what a constructor is it takes the instance variables that are in the class and reserves a spot up in memory for those 4 variables for that cookie. Now you could have another cookie that's on a different spot of the screen, the same shape, right? So each one of our cookies that we cut, or each one of these shape 2Ds that we cut, are going to have their own set of variables up in memory. So we need a way to construct this. We need a way to make a shape 2D. So we need to add a constructor. Now what's weird about the constructor is that the name has to match the class name, which matches the file name. You see all these different parallels. The name of the constructor has the name of the class. So you say public, and then usually what you put next is the return type. Does it return an int, void, a double, a string? Well, with constructors don't return anything, not even void. And that's how you can tell it's a constructor, is it doesn't have a return data type. All it has is the same name as the class. So here's the shape 2D. It's got the same name as the class, but this is not a class name. Notice it has the open and close parentheses at the end. That tells you it's a method. It's not a class name. Now this constructor takes no parameters. That means there's nothing inside between the parentheses. So we're going to have to initialize the instance variables to specific kind of null type values. So the main job of a constructor is to initialize the instance variables. So what that means is we take the instance variables and set it to some known state. So we're going to say the width is 0. Let's put x first. So we'll say x is equal to 0, top left corner of the screen. Y is equal to 0. Width is equal to 0. And height also equal to 0. And that's a proper constructor. Its job is to make sure that when we cut that cookie, that at least we have some numbers in there, not just random numbers, whatever happens to be in that location in memory. We want to set it to a specific value. But right now, we have a problem. And I want to show you where the problem comes in. I'd like to create one of those shape 2Ds in here. So I'm going to say this. This is our test program. You remember the main method is the entry point to every Java program. We do it like this. We say shape 2D. And then you give your shape a name. This will be the name of the object. I usually use the word my to indicate that, hey, this isn't some language feature or isn't this class thing. This is actually an object. So when I say the word my, this is my shape. Okay? I can make another shape 2 and another shape 3, my shape 3, my shape 2. So this is a single instance, a single cookie that you're cutting. Okay? So this is going to be the name of our cookie, the name of our shape 2D. And we say new, because we're creating a new one. So there's a keyword that you need to use when you want to create a new object, is the new keyword. And that's the first thing that you need to do when you're creating one of these things. And then you say the name of the class again. But this time it's not the name of the class, it's the name of the constructor. And we know that because we put the open and close parentheses at the end. That makes it not a class name, but a call to the constructor. And now we just created in our code a shape2D that's up in memory and has those 4 variables in it. Problem is, this isn't very useful because, well, we've got this shape. It doesn't really have a shape because it's up in the top left corner. It has 0 size and 0 width, and it's at 0, 0. And so you're not going to see it if you try to show it on your screen. Not very helpful. It'd be nice if we could move it out maybe to the middle of the screen and then change its width and height. Say we're making a rectangle. We'd like to be able to change the width and height. But right now, once we create it, we can't do anything with it. If I go right now and I say my shape dot width equals 5 pixels, the compiler doesn't like that. It doesn't let you do that. So, well, how am I going to move it and size it? How am I going to be able to do that in my code when I can't get access to the width variable? So, because if you look back in our class, you'll see that our instance variables were declared private. That means nothing from outside this class can get direct access to these variables. These variables are not accessible. They're private and hidden inside the class. Hey, come on in. So we need to provide a means so that we can go in and get these values. We also need to be able to go and set the values or these variables to new values. Okay? So those are the get and set functions that we need to provide. Luckily, in this IDE, it provides a way to create them automatically. So it saves you tons of typing. Okay? So I'm going to show you this trick, and you can use that later on in the class. If I go to the refactor menu and I say encapsulate fields, these instance variables are also known as fields, and now we want to take our fields and we want to put them inside our class and hide them from everybody else, but still make them available in case somebody wants to change them or just get them. So I click on encapsulate fields, and it gives me a list of all the instance variables. You can see those here on the left. And then if you want to create a get and a set for each one, you just click the list, the checkboxes here. And for each instance variable, it's going to create a get function, which is called an accessor. You're trying to access the data. And then a set function, which is to change the data. As soon as I have that selected, I say refactor. And you'll note now in our code, there's all these get and set functions that you didn't have to write. Those are written for you by the integrated development environment. I used to have to type these in by hand. And when your object has like 27 variables, typing this all in, and they're always the same shape. They have the kind of the same layout. So finally somebody smart in the compiler says, you know, why are we typing these in? These are take too long to type. So they made a little helper program to do that. Yeah. Yeah, you can copy and paste and change the names, but that's prone to error. If you have the computer do it for you, it does it right. Anything you can push off to the computer or the compiler to do that, because it's not going to make mistakes like humans typically do when they make these things. We'll go over how get and set functions work. I don't want to get into too much detail right now. Does anyone have any questions before I go on here? I know this is a challenge. Okay. So now we go back to our tester program that's here. We've created our shape and we want to set the width of the shape to 5 pixels. We can't do that. But if we say my shape dot Notice when I hit the dot, it gives me a list of possible things that might come next. We have get width, get height, all those get functions are there. You can see our set functions are listed. There's also some things that we inherited from the object class. There's a toString method, there's a wait method, there's a get class method, there's an equals method. But the ones that are in bold are the ones that we created. So we just want to set our width, so we just select that. And it tries to get what you want to do. And in this case, we want to set it to 5. So now we can go in, we created our shape, and we can tell the shape, okay, now it's a new size. The width is a little bit bigger. And we should do this for each of the different coordinates. So say we wanted set x, we can set it to maybe 20. Set y maybe 30. Our width is 5. Maybe it's 10. Look for my water bottle. I don't know where that is. All right. But again, this is a lot of typing. What we need, yeah, William. Oh, yeah. There's always a question about that. Why not just make them all public? That would make it so much easier. Well, that's fine for small programs, actually. You can do that. But once the program gets a little bit larger, say you have some systems I had like 60 or 65 different classes. And they all use each other's variables all over the place. And you get people writing to those variables from all these other classes. And say one of them messes up and puts an invalid value in there. Now you have to go look around to see where the bug is. Okay, which class actually messed up this class over here? And the answer is when you have that many classes, it's almost impossible to figure that out if everything is public. Like say in your set width function, say they put a width of negative 2,000. If it's public, it's an integer, negative 2,000 is valid, so it puts a negative 2,000 in there. And then you try to draw it and it blows up your program. And I go, how do I get negative 2,000 in there? And you got 60 classes to look through to see which one messed it up. So by having another layer over the top of it, you can test that in your set width method to say, hey, is this width greater than or equal to 0? Because anything negative, it doesn't make sense for this variable. You can do that check in set width. But if you had it just a public variable, all bets are off. So once your program gets to a specific size, that's the way we used to do it back when I graduated from college. There was no get and set functions. There was no double checking of the variable. And systems get to a certain level of complexity and then just fall down like a house of cards. This allows you, this simple thing just allows you to make much more complex system, much more robust, sturdy. They're not going to fall down. Seems like overkill, but you'll find that if you don't do this, you'll pay a big penalty in larger systems. So it would be nice if we could just set up a shape and give it these initial values without having to call the set functions. We want to initialize the whole thing to values that we send in the constructor. Problem is our constructor doesn't take any parameters. There's nothing in between the parentheses. See how that's empty? So we're going to create another constructor. And I'll just put it right after this one in Shape 2D. And what's weird about most object-oriented programming languages is you can have more than one constructor, as long as they look a little bit different. This constructor doesn't take any parameters, but this one is going to take the width and the height, the x and the y. So we say int x, int y, int width, int height. So here's another form of the constructor where this time we're going to pass in all the construction parameters in as arguments to this method. And we'll use that to initialize the internal versions of these things inside the class. So the way you do this, there's a name collision. If you say x, which is our interior x, is equal to x that's coming in as a parameter, so this first x, I want it to be this x down here, this private instance variable. And the second x, I want it to be this x that's coming in as a parameter to the constructor. The problem is they both have the same name. And the computer's really confused at this point. It's saying, which x are you talking about? Because what you're doing is you're setting it to itself. And why would you ever do that? You have it right at red. Why would you set it to itself? It doesn't make sense. So you have to differentiate between the x in the object and the x coming in as a parameter. You run into this issue a lot. One way to avoid it is just set the parameters to some other name. I just can't think of anything else. Like you could say ix for maybe integer x, and then the problem goes away. But what programmers typically do in constructors is they say, okay, the x for this object. So there's this key word called this. Very strange. It's similar to, there's the me object in VB. In game design, they had self. That was the equivalent in game design. There was self, other, and then an object name. You always had that choice between self and other in a collision event, right? So the equivalent for self in game design is the same thing as this in Java. Okay? By now you probably figured out that the game design program, or the game design class, wasn't really a game design class, was it? It was an object-oriented programming class. And what you learn is a lot about objects from game design, because we have objects. Objects have variables. The methods are the events, the event handlers, and the actions are the things we put in the code, right? But it's all graphical. Now we're doing it a different way, but the concepts still stay the same. You have this object. It has a location on the screen. We don't have sprites yet in this, but we might someday. So then you just keep going. Say this dot y equals y, and this is the y coming in. Notice it has a different color, showing you that's the parameter one, and the green ones are the ones that belong to this class. This dot width. So this now has all these variables initialized to the ones that came in on the command line or on the parameter list. So say we want to create another shape, but we want to avoid having to call all the set functions and get functions, or we could just use the same shape. We could do this. If we go back to our driver class where the main method is, instead of setting x to 20, we can just pass 20 in as our argument. Next one is y, so that was 30. Next one is 5, which is the width, and 10 is the height. And now these don't need to be called anymore. Okay. By doing it this way, you saved yourself a lot of typing because you're passing in the actual numbers you want it to be. I want it to be x coordinate of 20, 50, kind of top left corner area. I want it to be 5 wide and 10 tall. A lot more concise. Java programmers and C programmers like not having to type lots of stuff. We're desperately, terribly lazy. We don't want to do more typing than we need to. Before I went to college, I took a typing class because I thought you had to type all day. And you do type all day, but you don't type that much. A good programmer will write maybe 30 lines of code a day, which doesn't seem like much. A bad programmer will write 300 lines of code every day. Isn't that strange? The guy who writes 300 lines of code is a terrible programmer. And the guy who only writes 30 lines of code is a really good programmer. Well, why is that? Well, if you can write in a very concise way, the less typing you do, the less errors you'll make in your code. So the good programmer has very elegant solutions and doesn't write a whole lot of lines of code. They used to pay programmers by lines of code that they wrote. That was a complete disaster, okay? Because people would just make their lines of code these humongous things and try to do it in the most inefficient way possible just so they get paid a lot. It's the wrong incentive. You pay programmers by how few lines they write rather than how many. Yeah. Yeah, they just put in junk, junk that doesn't really do much. But the code was a mess and it wouldn't work. Ultimately, it'd be a mess. So programming is a very interesting art form in that the less you write, the better it is. It's like playing golf, right? You're on a par 3. There's fewer chances of messing up on a par 3 than there is on a par 5. On a par 5, you hit the ball a lot more, which means you're going to hit it into the water and into the trees much more often than you will on a par 3. So by writing really concise code, there's less opportunity for error and bugs. So our brains are full. We'll stop now. We'll pick this up next time. But I do want to talk to the people who just took Java 1 last term. And we're going to take a look back at our project. And I'll give you a few more hints on how we might go about do that. So new people into Java this year, you can rest your brains. But everyone else, if you could turn your ears on, we can go to the next part. Yeah. Yeah, that's only for the people who had Java 1 last term. So, right. Or if you want to do that, fine, you can do that too. It's kind of interesting, but we haven't got to that part of the review yet. So it's not an assignment at this point. Now this shape class stuff is going to permeate our entire term, okay? We're going to look at, we all know about geometrical shapes. Now, last term I talked about dates, and everybody knows that, it's January, February, March. Things that are familiar. Here, this term, we're going to be looking at objects, geometric objects. Eventually, we'll get to the point where we turn these things into video games, these objects. But we have to start from here. So this is a starting point for this. So don't lose this, because we're going to be building on this class the entire term, all right? So by the end, we have a cool game to play when we're done. Okay? This is the first step.